Okay, I'm back, and in the previous segment we talked about what was it that causes the seasons. Now we want to talk about what would happen if the Earth's tilt was different. Okay, so there's a couple of things I'd like for you to take a look at. So in this next slide here, we've got a simulation that I'd like for you to take a look at. So it's kind of a long web address there, but if you could put that web address and look for it. So it's entitled The Reasons for the Seasons, and it's a simulation. Okay, did you find it? All right, you'll notice that there is a slider that goes up and down, and what that slider does is it changes the position of an observer. So if it's in the middle, then the observer's on the equator, and then as you move the slider up, then the position of the observer can be changed up here to the North Pole. And you could also put the person down at the South Pole. The sideways slider will move the Earth around. Will move the Earth around the Sun. Notice that the spin axis is always pointing in the same direction. So the spin axis is pointing this way towards Polaris, and then as you move it around the Sun, you'll notice that the spin axis is always pointing in the same direction. Okay, then underneath it you see that yellow bar, and the yellow bar represents the rays of the Sun. And you'll note if you put it in the position of summertime, so move the sideways bar until the Earth rotates around until, let's say, it's July, then you should be noticing that the yellow bar is coming in more perpendicular to the ground. And then, now that would be in the northern hemisphere, so you need to put the observer, let's say, at 45 degrees, so that would be approximately Missouri, and you'd see that. Okay, then you can also move the horizontal slider until like it's December, and now you'll notice that the sun's rays are coming in at more of an angle. So it's going to be winter time in the northern hemisphere. Now the one that's right next to it though is a video that I want you to watch. So this video is entitled What If the Earth Spun Sideways on Its Axis? Okay, so watch that video. Turn me off. Alright. Okay, did you turn me back on? Alright, so you're watching the video. Okay, so if the Earth spun straight up and down like this, so the spin axis is straight up and down, then as the Earth orbits around the Sun, then every, let's see, in Missouri up here, it would be the same weather all year round because the sun's light would always be coming in at the same angle. So it would be moderate weather here, it would always be cold up here, it would always be hot down here. Okay, now we know though that the Earth is tilted at 23 degrees, so then that means that sometimes the northern hemisphere gets extra sunlight, and so sometimes the northern hemisphere doesn't get a whole lot of sunlight, so we go through the seasons. So whenever the northern hemisphere gets extra sunlight, summertime, when 6 months later, when it's not getting so much sunlight, that's going to be winter time. Alright, so we've done it straight up and down, we've done it 23 degrees, so then the next question is, what would happen if the Earth spun like this and its spin axis was sideways? So then that would mean, so let me hold it like this, and then here's our sun, and so let's put the sun over in here. So then that would mean that for part of the year, this whole part of the Earth, the southern hemisphere, would be in complete sunlight 24 hours a day and would be incredibly hot. This side over here would be in complete darkness 24 hours a day and would be very, very cold. Okay, then the Earth would still orbit, so the Earth might orbit over to here. So 3 months later, it would be like this. And now this part would be in getting direct sunlight. And so it'd be very hot here. And it would be still cold here. And it would be still cold over here. Okay, and then it's going to orbit 3 months later over to here. Okay, and now it's this side of the Earth that would be baking, and it would be this side of the Earth that would be in darkness and would be incredibly cold. So the point is, the seasons would be more severe. If the Earth spun straight up and down, then you wouldn't have any seasons. And then if the Earth was tilted at 90 degrees, you would have the most severe seasons. Okay, in our next, well, let's just do this one other thing, and then we'll go on to the next slide. A lot of students say that the reason that the Earth gets hot during the summertime is because that the Earth is closer to the sun. So they know that the Earth goes around the sun in an ellipse. And an ellipse means that sometimes the Earth gets closer to the sun and sometimes the Earth gets further away from the sun. So they think that because they think that summertime is a result of the Earth being closer to the sun during the summertime. Well, that's not true. So it says here that the Earth is closest to the sun actually in the winter time, the northern hemisphere's winter time. That's actually when the Earth is closest to the sun. And during the northern hemisphere's summertime, you can see that the Earth is 152 million kilometers away from the sun. So the difference between it being close to the sun and far away from the sun is only about 3.9%, and that would not be enough difference in the distance in order to produce any real change in the weather. So it is not because of the change in distance, it is because of the tilt of the Earth. Now, the closer the Earth is to the sun, so if we were to take the Earth and move it to where Mercury is at, well, of course it's going to be hotter. So distance does play a role in determining the overall temperature of a planet, but it doesn't play a role in determining the seasons on the planet. All right, in our next segment, we're going to talk about retrograde motion. I'll see you there.